Hi guys, and welcome to another development video. Today we're gonna continue where we left off last time with the movement stuff. I actually went ahead and improved the movement of the enemies a little bit off screen. This is what we now have. The enemies are a little more intelligent when moving towards the player. First of all, they now know how to follow the path, not just track towards the second point on it, so the first segment, but when they arrive at that point, they actually know how to continue with the following segments, which makes the movement a bit more efficient. I also improved or rather, I reduced the time between the path queries a little bit. So if the player makes some unexpected moves, they know how to change course a bit more rapidly. Now, of course, running queries against the nav mesh is something that can potentially be a little heavy on the performance, but it's worth keeping in mind that all that stuff is done only on the server, which by default runs in a background thread, and the nav mesh is going to be pretty small for the levels of this game anyway. So I think we can probably run it fairly often, even with a large amount of enemies. Let's have a quick look at what I did. So. No, we don't want an update right now. Okay, so Sublime is making my life difficult. Right, so I lowered the time between the path queries to 0.6 seconds, and I introduced this point arrival epsilon. So it's essentially the distance that the player needs to, or the distance that the AI character needs to be from a point to be kind of considered arrived at that point. So it's one unit currently. Remains to be seen if we need to tweak that. And essentially, when one of these guys has come 1 unit from a point, they are considered to have arrived at that point, and they can move on to the next point on the path. And we simply do it by checking the current position of the unit. Well, actually, first of all, we check that if we have a movement path at all. We check the current position and the current path point, and then we get the squared distance and compare against that constant that I introduced. And if we are close enough to it and we're not at the last one, then we just increment the current path point index. And that gives us this movement. You can see, like, if we move in a circle like this, you can clearly see that even without the visualization, which shows where those lines are, you can even kind of see that those enemies are kind of moving in like pulses, and that's of course because the path queries aren't run all the time. Like if you move in a straight line, you don't really see the path change because the enemies are just moving like in a straight, smooth motion, chasing the player. But the more you move around in different directions, the more you can kind of see them sort of like deciding on, like, oh, I need to go there, and then the direction changes and they go, oh, actually that's the direction, etc. But I think it works quite well enough now, and they don't really get stuck on obstacles the same way that they did in the last video. The only thing that they can't really deal with currently is this ramp here. So if we go up onto the ramp, they can't really deal with this this thing at all. And the reason why that is because the nav mesh doesn't cover this part. So there are a few things here that actually makes them jump. That looks weird. Yeah, I need to actually I need to look into why some of those seem to sort of the collision between them can get a little strange. Like if they spawn inside each other, they seem to like ignore each other's collisions. I think that has something to do with how the physics engine's character controller is set up. But yeah, in the final game, they're not really supposed to ever spawn inside each other. We'll have logic put in place to make that happen, and also they're not supposed to stand on top of each other. So these things should get fixed. But yes, this ramp. So let's have a look at the nav mesh in the level editor for an explanation on why that happens. I think I actually added a hyper project for this. Yes, I did, and we'll use that, and we'll load up the one and only level that we currently have, which is this temp level. And yes, like I mentioned previously, I'm planning to actually generate these levels out of sort of modules, so that they'll be sort of semi-procedurally generated. Okay, so why is this path not covered by the nav mesh? Well, it has to do at least partially with the width of these guys. So you can see that there is nav mesh on top of the larger ones. There aren't on top of these, which is actually probably a good thing. Like we don't really need any nav mesh up here, and that should probably be eliminated somehow. But the reason why there are on these and not on these is that the agent radius, which determines like how much distance we need from a wall, is set too high currently. So the agent radius is 1, and that's way too high. But I think even before that, the cell size is probably too high as well. This determines kind of like the resolution of the mesh. So let's put it down, and we'll rebuild. And this gives us a little bit more detail. It's still too large, the radius, so let's put that down to like 0.4 or something. And now you can see that now the system considers this top face here to be large enough to actually hold one of these guys. And you can even see it now extend on top of this. The reason why it sort of cuts through these is that it tries to keep the nav mesh a little simpler, so it sometimes cuts through the geometry. We can just add like a small drawing offset there, and you'll see that that's actually what it looks like, the nav mesh. So now they should be able to follow the player up on top of that ramp if we move there ourselves. So let's try that out. I'm gonna just undo that draw offset. It doesn't really affect the generated data in any way, but it shouldn't be needed. So let's get rid of it, and let's try running the level again. Right, so now they know how to get up there. They also know not to jump down. Like if we do this, oh no, one of the guys got kind of stuck. Yeah, there's bound to be some issues like this with ramps, and like I don't know if we're gonna have ramps in the final game at all, but this is just a test. Yeah, this guy now doesn't really, he can't decide between these points, so he's kind of tracking in an infinite loop like this. It's not great, but it doesn't matter. Like if we jump down, those guys are gonna go like, oh, we actually need to go the other way around to reach him. And as you can see, there are some like really tight really tight sort of what do you call it, turns and still cause some issues. And we have the guys falling on top of each other and whatnot. But yeah, the main thing now is that the path following is working quite nicely in all the like supported cases, and weird things like ramps still cause a little bit of trouble, but that shouldn't be really a big problem, because that ramp is mostly there just as a test case. All right. So, what would be the next thing then to do? Well, to make this into a twin stick shooter, I think the next thing on our list would be aiming and some form of weapons. Like some form of weapon for the player, so that they can start firing at these guys, killing them off, and then having the system spawn new ones in a sensible manner. And if we add player death to that, then we essentially have like the core mechanics of the twin stick shooter in place. So let's try to do that. Probably won't get all of that in this video, but let's start. So let's have a quick look at the components that go into these objects. So we have the player character here, and we have the enemy character. Transform and mesh, I think those we can live with for now. This thing is probably not going to change, because it's kind of a fundamental piece of the whole game engine. The mesh we might want to port to Zig at some point, but it's not terribly interesting. It just shows the mesh and it works perfectly well, so might want to leave it. But we have this movement component here, which is the C++ version. It's the old version, which contains a lot of unused code and whatnot. For the enemy, we already ported this over to Zig, so that's fine. But I think we should probably do the same thing with the player movement component. And or should we? Let's have a quick look. It's this character movement component, isn't it? Yes. So we don't have almost any components on the game side currently. Those are just essentially part of the technology. And so truly the only C++ component in this project currently is this character movement component. It would be pretty nice to actually just get rid of this guy and get it ported to Zig, and then we would have like all the game components in Zig essentially. Yeah, but maybe I'll do that off screen, because it's not terribly interesting content. The character movement works currently as it is, so let's leave that. But yeah, if we consider the next step, then that would be the aiming. So if you have the character here, currently we can move the character with one stick like this. And the other stick, which currently doesn't do anything on the gamepad, is supposed to control the aiming. So Like if you move it up, it would point in that direction, and left it would point in that direction. And then you could fire with like a trigger or something like that. And that is the twin stick shooter input in a nutshell. So we should probably just make that work. So how do we do that then? I think we can already read the input from Zig, so that should be fine. Let's go have a look at the slide Zig code, because that's where we do that. So Zig components, source. Yeah, it's probably this one. Yes, we have an input manager here, and well, yeah, we actually don't need that because it's only used here to set like contexts, but we already have the correct input context enabled because we can move the character around. So essentially we just need to add the aiming controls and then read them somewhere. And in this context here, we have I think it's an avatar tracking component because it's really the only one that can read input. We can read ranges, states, and actions. So the aiming would be a range because we're essentially tracking like two axes. Okay. So here's another thing that we currently can't do in Zig, and that is adding actual input IDs. So if we go to Input IDs and we want it in hyper, yeah, what do we have? These are mostly just slide testing things. We have like vehicle IDs here, cruise control. We can get rid of most of these. So let's actually do that. But before we do that though, let's do controller manager and look at where they are mapped. So let's make that a little bigger. So yeah, this is just an enum which sets up the numeric IDs, and then we init a buffer description, and we tell the system what they actually are. So for example, you have the forward backward movement, that's a range, and the left right movement is also a range, which goes from -1 to 1. And then we have things like actions, which are like input ID back. So we can perhaps just do a little bit of cleanup here and add the IDs that we actually need. So yeah, let's have the pause game and debug pause. Debug pause is the one that I have been actually using all the time. By pressing P, it just pauses the game so that you can move around the free camera and whatnot and look at things from different directions. And then we have the free camera. That's pretty good to have as well. We can get rid of the vehicle stuff, and we can get rid of the cruise control things. Then we have some more camera things, trailer connections. We don't need that. We will need a fire weapon, so let's have that around, and maybe we'll want a switch weapon as well at some point, so we can do that as well. And we don't need those. We're not going to be able to move the camera, so let's get rid of that too. And I think we can just simplify the names a little bit here. So let's just move input ID forward backward movement, left right movement, right? And And we can get rid of those. So here are the contexts that I mentioned earlier. So all the inputs are added, mapped to something like a keyboard button or a gamepad button or something in a specific context. So in slide, for example, you can control a vehicle, or you can control a crane or something like that, and depending on the context, a different gamepad or a gamepad stick might do different things in different contexts, for example. But in Hyper currently we're mostly interested in this character control and the free camera contexts. Okay. So now that we have removed those, we need to actually remove them from here as well. Just take all of this away and take all of that away. We remove the back as well and the camera movement, and we'll just remove those. And that should be it. Okay, and now we actually want to map it to something. So again, we'll just remove most of this stuff. And of course the mappings are things that you would in a final game probably control through some kind of key binding menu or something. But since we don't have that set up yet, we're just doing it in a hard-coded manner. Oh, come on, don't format my stuff. I don't want to. Like this, and yeah, we have the fire weapon thingy there. Maybe just take these out of there and put them here, but actually we want them to be in the character control context. Right. All right, so now we should have essentially only the input mappings that we need, and this will be character controls. So the way this works is that you take an ID such as fire weapon and you map it, in this case, to a mouse button, which is mouse button left in this character control, and this just means that it will be mapped only if the mouse is locked. So for example, let's not build now. Like currently the mouse is unlocked. Like I can move it around like this and click things and whatnot. Then if I press F2 currently, the mouse is locked, and it can be used for things in the game, such as aiming, for example. Right. So escape should actually be mapped to pause in the character control. Context and the debug pause as well. Except that's probably, yeah, I think this debug in-game control context is always mapped currently, so we can just leave it for there. And then for the final game, where we don't actually want the player to be able to pause the game by pressing P, we can just not enable that context, and that should be fine. All right. And yeah, switch weapons can be done either by pressing Q currently, or the gamepad button Y. Of course, we don't really read this anywhere, so it doesn't mean anything, but this is just good to have there, because I think I'll want different weapons in the final game. Okay. I think we can actually try to build this now, and it should still work. It should. All right, we changed it. We removed the character from this. So that's not going to work until we remove it from the place that actually uses it. Yes. So this works, and pressing P still pauses the game, and so that's good. Okay. Then, as for the actual aiming, we need to add input IDs for those ranges as well. So let's call them something like input ID aim. What do we call them? Like horizontal, and input ID aim vertical, right? And we would map these probably to the mouse movement, as well as to the right gamepad trigger. So how did we actually map mouse axes? We can probably see it here in the history. Like I had previously mapped the camera movement to there's the gamepad stuff, and where is the camera H? Okay, so it looks like this. So it would be horizontal would be input source mouse X relative, and I scale it by something here. That will need to be kind of figured out if that's a good scale or not, but we can leave it for now. And then the vertical would be Y, and that's fine. But the more interesting thing perhaps is just mapping that to a gamepad to a gamepad stick. So it works like this instead. So you have the horizontal, and that would be input source gamepad right thumb axis X, right? And then we have the vertical, which is the same except it's using the Y axis. Okay. All right, and we also need to tell the system, before we can map it somewhere, we need to tell it what kind of input it is. So those will be ranges, both of them. And we can just... Oh, I'm not thinking straight. Like this. And that's a range, and that's a range, right? And this is actually something that's kind of interesting. If you're making multiplayer games, like what do you put in the input buffer? Because that stuff actually gets serialized and sent across the network, so that inputs can be read on the server. Like you can have things fire on the server due to input being pressed on the client, like firing a gun perhaps is perhaps a good example of something that you don't want the client to be able to tell the server that, hey, this guy fired a gun and he shot this other person, because that opens up the possibility of cheating. Instead, you want to have the input sent to the server on every network update, and then have the server decide that, okay, the fire input was pressed, can we actually fire the gun, and then the server is firing the gun. But because of this, there's an input, or there's an output here, which tells the size of the input buffer in its uncompressed form, which we should see somewhere here. If we have a look, where is it? Input buffer size is currently 42 bytes, and yeah, it gets compressed when it's sent across, but still, something to keep in mind. We shouldn't have any unused IDs like we previously had, because it's gonna bloat that buffer. Okay. So now that we have those inputs there, we should already be able to read them on the Zig side, because Zig actually knows how to read this header. You can see some hints of it here. I need to include some things when Zig is reading this header, as opposed to the C++ side reading it. So maybe we'll actually add like an aiming component to our player now. So what do we call it? Player aim component or something like that. Let's just copy this guy, and we do want it to be a avatar tracking component. So the context is an avatar tracking component, because again, only the avatar tracking components can read input, because only avatars are ever supposed to read input. So we get the whole input reading functionality through the avatar tracking context. And let's register this player aim component, and we need to actually bring it into this module as well. And let's see if that works. File not found. Playing aim component. What? Player aim component. Okay. Okay, so that works. And now we can actually get the input range here, and use it for something. So the first thing we'll do is we'll print it out to make sure that it works. So up down should be an F32. And what did we call it? It was vertical. Let's just call it H and V. Horizontal, right? And I can never remember what this is supposed to look like, so just copy paste it all over the place. V and that's just H and V. Of course, we can't just do that if we aren't a local avatar. So let's have a quick look at the context. Or actually, if we are is client local avatar returns true on the client only, but of course we want that to be read on the server as well. So we can use this get have avatar host ID instead, and self context. If this isn't -1, we did this previously in a video. That that essentially tells us are we someone's avatar, either on the client or the server. And because we're mainly interested in the server side here, we can just do on server. If we're on the server and we are someone's avatar, then read the input ranges and print them out. All right. And so now if I play around with no, of course I need the context there. Context. Now if we play around with either the right mouse stick or the mouse, or move the mouse in locked mode, then we should see those values change. So let's try that. Oh, and we don't, and of course we don't, because we haven't added the component to the player yet. So let's do player aim and player aim component. Did I, by the way, just quickly check? Yeah, it's created on both the client and the server. That's what we want. So there's 0, as you can see. Now if I start moving the stick, they change. So this works just like we want to. And what if I lock the mouse and then I move? Like that works as well. Okay, so that's good. This is actually kind of an interesting thing. Like I try to move the character now. Obviously, this case is never going to happen in the game where I'm surrounded by enemies, but essentially I have no way of moving now because I can't push those other characters away. I mean, they would have killed me already ages ago in the final game. We can just kill some of them off through the debug menu, and then we're free. And then we can be a real asshole to them and do this. Let's see if I can then kill the ground. Damn you. Some of them managed to get onto my platform. Okay. Okay, so now we can actually read the aiming input. So how do we actually translate that into like an aiming rotation? So basically what I want to do here is whenever the game starts, the aim is going to be in some direction. Maybe we'll have like a laser sight or something. Probably just a debug line for now, just like these yellow ones. And so it's going to point in some direction, and when you move the stick in this direction, it should kind of rotate around the guy. So the aim direction is essentially just like a rotation around this guy, if you will. But yeah, we'll want to somehow translate that from a stick direction into a rotation. Then it should stay in some orientation. Okay. How do we do that? I actually haven't really figured that out yet. We'll figure it out together. Okay. So I think we should actually have what we need here in the character movement component, because if you think about it, when you're moving around the character with the stick, you're setting this movement vector to be the direction that you want the guy to move in. And essentially we'll want to do the same thing with the aiming. We just want like an aim direction. So essentially we have everything we need here already. We'll just want to translate this to Zig and put it in our new component. So this input reading we already do. We have the floats, and what we do is we put it in a 4D vector with the horizontal movement in X, the vertical movement in Z. The Y component is 0 because the movement is the movement doesn't go up or down. It's just flat on a plane. And this last W component is also 0 because if you take a vector 4 with the W component as 0 and multiply it by a 4x4 matrix, then you get a direction. If this was to be 1, then we would actually not get a direction but a position. And what we want here is a direction. So essentially this will give us the direction in world space on where to go. And then I just normalize it and set it to the movement vector. So this should be basically exactly what we want. So the problem here is that we don't have this guy on the Zig side. And indeed, I think we don't even have a 4x4 matrix class on the Zig side. Let's have a look. We only have a matrix 4x3, but that should be enough. I don't know why I actually even use a 4x4 here. And yeah, this is really gnarly stuff. As you can see, we have this message: character camera input to world matrix updated. I think this is something that's sent by the player controller. Yes. So this gets pretty deep into math land already, but essentially we have this camera director, which we'll actually get back to at some point to tweak the camera, how it behaves. But this guy has an input to world matrix, and basically means that when you look at the game like this from the camera's perspective, and you have, like, for example, this left side of the character here, if you have a vector that from the camera's perspective goes to the left side, then what does that mean in world space? Which direction is this going? There's no sense of left in world space. It might be something like north, east, or whatever. And so this matrix here is a matrix that tells you, like, okay, if you give it a direction to the left from the camera's perspective, what direction would that be in world space? And so that's exactly what we want. Then there's the added ugliness of the message parameters not taking matrix 4s, so I actually just package it as 4 vector 4s, and then repackage it as a vector 4 here once I've gotten those vector 4s out. So lots of ugly stuff, but it's fine. luckily, we don't actually need a vector 4. We need a 4x3 matrix. It will be enough for this kind of transformation that we want to do, and we actually already have one in Zig. So let's take this stuff here, the receiving of the camera input to world matrix, and just port that to Zig. And let's start by that. So it's called mat43, and we can put one of those guys here. So that would be mat43, and of course we'll need to actually bring that into this module. Like that, and then let's look which message category that message belongs to. So it's hypergame logic, and we already probably have parent created. Let's use that. So category hyper game logic. This is the place where the auto completion would be very nice to have. I need to figure out why it doesn't work, the ZLS project, one of these days. And I probably actually need to init that to something, like let's init it to identity, just so that we don't get any complaints about not initializing it. And for those who don't know, an identity matrix is essentially a matrix that if you try to transform something by it, it's like it doesn't do anything. It's like taking a value and multiplying it by 1. Nothing happens. Okay, and then we'll want a message received, which will also handily copy from another one, and we'll take this fairly long message name, and we'll do something like this as well. So these will be just const. Right. And let's try to translate this into our Zig equivalent. And so that becomes self dot replace all, and we don't actually have, well, first of all, we don't need these W's. Let's leave those out for now, because it's not a 4x4 matrix, it's a 4x3 matrix. So it has 4 vectors, but they're vector trees essentially. So it becomes something like this, right? And yes, I really should just have functionality for packaging these kind of things. But let's try to not develop that much technology in this video series, instead concentrating on the game. Okay, so let's build that. Probably made some mistakes anyway. Yes, we have. Right. Probably missing the. No, what was it? Message category. Right, but it's. This is probably. Is it engine messages, perhaps? No, they're game messages. Okay. Message character. Yeah, that's probably the problem. Yes. So engine messages contain things that are contained in the core engine itself, and this is obviously game thing. It has the hyper name there, so it needs to be game messages. Okay, cool. And now then, now we can do something quick where we're going to want to draw the direction as a line, right? So we'll need one of these guys where we can use the debug draw functionality to draw the line. I can get rid of that. And so what we'll want to do is essentially take this logic here and render it, right? So how do we actually do that? Well, we can, for the time being, we can draw things on the server. So let's do this only on the server, and let's figure out the client side later. But yeah, that won't work. So let's do that, and then yeah. Okay, just leave me alone. I'm going to fix it. Actually, we want that because it's the if. Right, so we have the horizontal and vertical, and we can't do this because again we don't have operator overloading like this in Zig, unfortunately. So let's comment that out for now and see. So we'll want to have whoa. I want to have like a vector 4, which is I assume we have an init function for it. Yes, we do. And that's going to be horizontal, and then again the like up down direction doesn't change. It's also always it is always 0. And then we have the vertical one, and then the fourth component is also 0. And I always automatically add the f's there, but Zig doesn't want them. And of course we'll do this, and then we'll want to multiply this by the matrix, and can we actually do that? No. Okay. Well, that's not great. That is not great. Then we're going to have to actually make that happen. So where is my multiplication by a matrix 4 or vector 4? There it is. So that's what the math looks like, and we'll actually add it here. And it's public function. Let's do like mult. I don't know, transform maybe. Transform, and we'll want to have like a self, and then a vector 4, which we can just call v, and this will return a vector 4 as well. All right, and this should all just be const. Oh, come on, like that, and then it'll be something like this. Do we already have the vector vec4 here. We do not, so let's add it as well. And maybe we'll call this actually transform vec4 because we'll might want to have like a vec3 version as well. Yeah, I think that should be it. So everything on this line is just floating point math. So here we can actually use the same pluses and multiplications. Okay, good. So what we'll get out of this is like it's a transformed vector 4, and we'll have the self dot camera to input world matrix. We multiply, transform vec4, and we'll give it the vector 4. And after that, we can get would you look at that? We actually had a transform here in the vector 3. Did we have a? Oh, come on. All right. Well, this was annoying. I already had it. It was just in the vector 4. So let's actually undo that. That was my bad. I had done it, but I had it here, which actually makes perfect sense because then it is the vector 4 that kind of tells the system that, okay, this is what we want. We can just call it transform. Right. So aim. So this would be vector 4, and we'll transform it by self.camera input to world matrix. And then I saw that we actually have or don't we? I thought we had like a from vector 4 here. We have an init from vector 3 here, so let's just add the opposite. So like this, and we'll actually just we will just ignore the W component like that, and then we'll need something like this. Right, so given a vector 4, we just strip out the last coordinate and return it as a vector 3, which is what we want here. And which this thing on the C++ side already does for us, because we can assign a vector 4 to a vector 3 because of operator overloading, which Zig doesn't have, which has both good and bad sides to it. All right, and then we have like the vector 3 here, and we'll actually make that into a variable and not a constant. Well, maybe we don't need that either. We can just do this. The closing brace is moving along with me. So vector 3, and that would be vec3 init from vec4, and we have the transformed vector 4, and then we do normalized there. And we probably can't compile now because we need to do something like that. And we need to do vec3 basis math same thing for vector 4. Okay, so that works. And now, what? Now we can do something like line length is, I don't know, 4.0. And we can draw a line. So actually, this is now our aim direction in world space. This vector 3 here, and we'll want to do something like this, where we let's get the position of the guy. Let's get the position of the guy. Something like this. And we'll get the line end will be position plus aim direction, and again we can't use operator overloading, unfortunately. So how should we do this? Maybe we'll add something like multiply float, and we'll have self vec3 and f as the float, and this will return another vector 3, and we'll just actually we could do this. Right, and now we can do aim direction line length. So this will be one end of the line, and of course we'll want to draw line 3D. Start the line from the position of the character, and the other end is that position plus the aim direction multiplied by 4. So basis color, what do we call this? Orange, maybe, something like that. Maybe that would be visible enough. Right. I wonder if I should change the way that I import these things, but because I keep running into not having imported things. Should I like bundle them together somehow? I don't know. Okay, so let's see if that works. No, it doesn't work. Let's have a quick look. So I really need to figure out why it shuts down when it runs into an error on the Zig side. That's not great. But for the time being, I think this part should be fine. It's probably the rendering, the drawing stuff that's breaking it. Yes. So let's see what we did wrong. It's an update. We're ignoring the delta time. If we're on the server, we get those two. Transform by the matrix. Yeah. let's limit the area of failure a little bit. I wonder if it's actually those input ranges that are failing. Yeah, it actually writes some nice information for us there, but I can't actually. I don't have time to read it, unfortunately. Yeah, that's something that I'll have to figure out offline, like how to actually get to see that information, because it will probably tell us exactly what the problem is. So it's probably something with these guys. Let's just make sure. Oh, yeah, it's probably that, right? I bet it is. I didn't remember to add that avatar check there. And of course, forgetting something like that shouldn't make it crash, but that's what we currently have. Okay, well that didn't help, unfortunately. Update. I mean, we're doing exactly almost exactly the same thing here, so again, we can't do that. I need to comment it out a separate way. Okay, so that works. So it's actually not the input reading then. Okay, curious. Something with this. Maybe we should hold off on that until has received matrix, and that's a bool, and it is false. And that would be self. And that's true. Yeah, then again, we do initialize it to identity, so curious. Okay, well, that seems to be fixing it, though. We still don't get like a line anywhere. So it seems to me like this doesn't get called. And why would that be? Why would that be? Oh, I know exactly why this doesn't work. Yeah, so the server has no idea about the camera. That's a purely client-side thing. So this message won't ever be received on the server. So we can't do this currently. Yeah, that's a bit silly. But it is what it is. Let's keep this around because we'll probably need it later. I'll just do that. And then we can, I mean, this is very clearly like a client-side thing right now because the end result is drawing the line here. So we can just do essentially this is client local avatar thing and call it a day for now. So if we are the local client local avatar and we have received the matrix data, then we'll try to render that aim direction. Nope, that doesn't work either. Oh, that's curious. Yeah, I'm sorry about this not going according to plan. That's sometimes what happens in game development. Most of the time, actually, when it comes to my stuff. Okay, so that works. That's fine. And I'm guessing that this will work as well. Let's have a closer look at what we're doing here, actually. So we init a vector 4, we transform it by that, which should be fine because we have received the matrix, and then we init from the vector 4. Did we make a mistake here maybe? Init from vector 4. No, that should be fine. And then we normalize it. It's actually this, and we call normalize. Huh. Yeah, that breaks it. Let's leave that out. Like there's an assert here that the length is supposed to be more than 0, so that might actually just bring it down completely if we don't have like a proper handler for this assert. So I'm thinking that's probably it. I don't know why it would not have any length though. Yeah, so that's clearly what happens. That is clearly what happens here. And that begs the question, what does that thing actually contain when we receive it? Let's print the aim direction for now. Again, have that thing there and get rid of that. Oh. Yeah. I'm being silly here. I'm being very silly. So, of course, if we don't give any kind of input, then this will be 0, and this will be all zeros, and then the transform will be all zeros, and then everything will just be all zeros. Yeah. Of course, that's very, very stupid of me. So let's just, for now, I'm not sure how this will be handled in the final game, but let's just for now make it so that if if we actually have any values in these, then we will draw that line and something like that. Would you format it for me, please? Thank you. Oh. Oh. Yeah, that looks better. Okay. Yeah, it is showing a line. It's not perhaps exactly the direction we want. It's kind of jumping around a little sporadically. So that's not good. It's also flashing a little bit. I wonder why that is. So we have something wrong still in our math, but now at least we do get something on the screen. So let's actually print the same direction now. That would be, well, that's in world space, so that might actually make it a little tricky to realize like what is actually going on. It is possible that we have missed something here, or just like done these the wrong way. We won't need that matrix stuff though, because that wasn't the problem, and indeed it shouldn't have been the problem, because we initialize it to identity, which should just handle it gracefully. But yeah, I'm pointing the stick pretty much exactly upwards now, and as you can see, the thing is pointing. It's actually pointing towards the origin, I think. So that's a hint for us now. Like if we move towards it. No, it's not pointing toward the origin. It seems to be pointing toward the origin in certain cases, but not all of them. Okay. Hey, math. It's not easy. So camera input to world matrix. What is going on? So left, right. Oh, wait a minute. We're clamping them here too. That should be fine. I don't think we should ever have anything beyond the clamped range. Yeah. Yeah, I think I'm gonna pause the video here and figure this math out, and then I'll be back when I have it. 1 second. Okay, I'm back. So we actually had a few different things here. Like the biggest problem was that I actually had made a copy paste error in this. I had all of these as like this, which meant that the matrix was corrupted when we got it. Again, a good reason why we should actually just have a function for packaging these together, but now that's handled. And then of course we had an and here, which means that whenever we were pointing in like along one of the axes, one of them was 0 and it didn't render, so it needs to be an or. And now if we build this, we should get a better result. So let's have a look. Now if I move around, I still haven't touched the other stick. So let's aim to the left, for example. We have a nice line there, and we can rotate it around like this, and it works quite nicely. It might be a little difficult to see. Maybe I'll actually change that to yellow. Yellow seems to be slightly better, slightly more visible, at least in its current state. Actually, we can even let's just do it like this. We can draw sphere, and let's put the sphere at the line end and have it to be 0.2 and white, for example. It should be even more visible. Now you can see it better. We can actually like aim at those guys, and now we could shoot at them while moving in the other direction, which is what we want for a twin stick shooter. If we use keyboard and mouse, this is now you can kind of see it working, but it jumps around like way too much, and I need to tweak that input, and I also need to put like a smoothing factor on it. So rather than jumping around like this, like you can sort of aim if you try to semi-smoothly move the mouse in a certain direction, but it's not great. The math is correct; it just needs a lot of smoothing and tweaking. But with the gamepad, it's not actually a problem. One thing that you can see here is that it's sort of jumping around a little bit. Like now, I hold the stick just fixed to the left, and you can see that it's not moving around exactly with the character. Now, why would that be? And the reason for that is that we use the context get position, context transform get position method to get the position of the character, and then we offset from there. And that's the physical position of the object in the world. But the visuals are actually interpolated. Like you can see in the upper right corner, we're running at a fixed 120 FPS currently. The physics simulation is actually fixed at 60. And so you would think that it would actually be kind of smooth, because 120 is exactly twice of 60, but it's not exactly smooth. The physics is sort of it's not updating as often as the visuals are. So how do we fix that? Well, we actually need to get the interpolated position of the character. And here in component context in the transform API, we have something called the scene node, the render scene node. So scene nodes are a way to create sort of hierarchies of things in the world and have them move around whenever like the parent moves, etc. So we can use this render scene node is the one that gets interpolated. So since we're on the client, this can't be done on the server like you can debug draw on the server under certain circumstances, but you can't get the render scene node on the server ever. So luckily we are on the client now, at least for the time being. So let's get render scene node, and that would be self context transform render scene node. And if we look at the render scene or the scene node, I mean, scene nodes can be used for other things than rendering. It's a math concept more than a rendering concept, but in this case it is the scene node that's used by the renderer. So this has a bunch of functions for getting position, orientation, scale, etc. And it also has a position. We need to give it a coordinate space. So in which space do we want the position, and so let's do that. So actually let's move this guy up here and get rid of that. So we have const pos equals render scene node get position, and I think it is basis math space world, which sounds like a theme park, but it is actually coordinate space local parent world. Oh, it's actually called coordinate space, is it? Coordinate space dot world. No. That needs to be a variable, probably. Yes, needs to be a variable so that we can, even though we're not exactly changing it, we're calling get position, it still needs to be a variable currently. So now if you move around, there we go, now it is. Now it's not jumping around anymore. And it still looks kind of crappy, and it's pretty hard to see actually, but with this we should actually be able to add weapons and projectiles next, which is really fun. That's where the fun starts. And we'll make this, we'll add a much nicer visualization to this one that doesn't use debug draw. But this is a good start. And I think I'll actually just to sort of get going with the actual game development of this game. I'll do the weapons next, and I'll get back to this aiming logic, add the smoothing and everything. Like it is almost impossible to use with the mouse currently, but it doesn't matter. Like I'll use the gamepad, and actually we might just be able to scale it down. We have it here, so let's actually just try to scale it down and see if that helps. That makes it less jumpy, just as a very quick fix. It does, but it's not great. Yeah, and also one thing that is kind of annoying currently is the fact that you need to like move the mouse or keep the gamepad stick pushed to actually have the aim direction visible. So let's actually just add here like an aim direction vector tree, and we'll set this to, we need to set it to something so that we have an aim direction in the very beginning of the game, and it might as well just be unit x. Oh, unit x. think that's what it was called. Unit X, yeah. So it's pointing along the world x-axis, and with that we'll want to move this to the tick. Actually, we'll still want to have this drawing here, but let's do, so we have aim direction. We can just do self.aim direction and we'll actually do self.aim direction squared length like this, and we don't need to read anything here either. So if this is essentially just a check that, okay, do we have any length in the aim direction? Use squared because it's cheaper to calculate than the length. And we get the render scene position, and then we render it there. And here we do self.aim direction, and we can get rid of that, right? So in the tick we read the input, and here we use it to render, and that should be fine. Now it should stay regardless of if we let go of the controls or not, which is actually what we want. And that should actually make the mouse input a little easier to use as well. So let's try that out. Right, you can see it starts along the world x-axis, and now we can just aim somewhere and let go, and it will stay in that direction. Yeah, so yeah, the mouse is still very, very erratic. So I'm gonna need to look at that. Maybe the mouse actually needs to be like you can kind of rotate it quite nicely, but I think we might need to calculate it a bit differently than the gamepad input. But yeah, this is good enough for now. Let's start adding weapons and killing enemies next time. That's something I've looked forward to being able to do for a while now. I'm just gonna do a little bit of cleanup here. Okay. Cool. This was an episode where everything didn't go according to plan, but that's life in game development for you. Cool. Thanks for watching as always, and I'll see you next time. Bye.